25 here. So we've got a double angle formulas going on. We know we're in the third quadrant. We know what sine is. So where are we going to need to work? Let's do it up here. Third quadrant is here. Our triangle is going to look like this. Sine is opposite over hypotenuse, so we know we've got a 25 and a 24. 24 is negative. I guess you could do that. Notice the cosine will also be negative because it'll be up there. But what's its length? We just use the Pythagorean theorem. Again, it's going to be 25 squared minus 24 squared. I've got this listed, this coordinate down here, so the length of a side is not negative. And then we take this square root. Pythagorean theorem, c squared minus b squared equals a. That's what a is. So this is 225, what's that, 625? 25 squared, yeah, 625 625 minus 24 squared is 576. And when you subtract those two, we get something. We get 49. That's cool. You never knew how happy you would be when you got a square root that is nice. So it's 7. And again, we can think of it, it's a negative 7 because it's in the third quadrant, so the x would be negative 7, the y is negative 24. So yeah, this point down here is negative 7, negative 24. But what that allows us to do is come up with all these other, what we really need is we need to know what is the cosine of theta. We don't need to know what theta is, but what's the cosine of theta is going to be adjacent over hypotenuse, so it will be negative 7 over 25. A lot easier to work with. So then we want sine of 2 theta. We have to go back to question 1 to get these formulas, but that's what we have. So it's going to be 2 times the sine times the cosine. So A is 2 times the sine of theta, negative 24 over 25 times, sorry folks, it's kind of messy, cosine is negative 7 over 25. Negative and negative is a positive. 2 times these, the denominator, 25 times 25, we did that earlier, that's 625. And then 7 times 2 is 14. 14 times 24 is 336. And that becomes positive. Does that reduce at all? I wouldn't expect it. They don't seem to have common. 5 goes into 625, that's for sure, but 5 doesn't go into the other. I think that's about as good as we can do. So that goes for A. For B, we've got cosine of 2 theta. Now we've got several choices. We could do any of the ones, whatever your preference. Cosine squared minus sine squared. I don't know, we gotta square something. How about this last one? 1 minus 2 times sine squared. So that's going to be 1 minus 2 times sine squared. Sine squared is this. Is negative 24 over 25 squared. So that's equal to 1 minus, as we square this, so 24 squared is 576, right? We got that up there. So 2 times 576 is 2 times 576 is 1152. Okay, so we squared it. This is going to become positive because we squared it. It's 576, and then I multiplied it by 2. The denominator is our 625. Now, the thing you got to remember is, what is 1? 1 is 625 over 625. That's how we get the common denominator, minus 625 over 1152. Subtracting, we're going to get negative okay, so watch our signs here. Negative 1152 minus 625 gives us 527. Okay, so that's the A answer. This is the B answer. And then for C, there is no tangent formula, but again, remember, tangent is sine over cosine, so we can do that one with the ratio. So we'll do sine of 2 theta over cosine of 2 theta. And remember, so think of it as sine 2 theta divided by cosine of 2 theta. So we've got two fractions. So the first one, 336 over 625. And then when we divide by a fraction, we flip and multiply. So then it's 625. It's the reciprocal of this with a minus, right, over 527. 625's cancel, and then so our answer is negative 336 over 527, and that's our answer for the C part. Okay, thank you.